mass spectroscopy of elements in Unit 1.2 in AP Chem. So today we're going to talk about isotopes. What are isotopes? Isotopes are something that have the same number of protons but a different number of neutrons. That's all that matters, okay? So I'm going to do this pretty swiftly, but I could have an oxygen that has 16 protons, but this oxygen could have 17 neutrons, okay? A better way to write this is probably how you'll see it. You'll have like 19, 16. Oh, this means this is the element, so this is oxygen. Element. I should not use this much white. Let's go black. So this would be the element you have, so oxygen. This is the number of protons and electrons for our case because this is not ionized. And this is the weight of it, or actually, what you do is this is technically the weight of it, but so to get the number of neutrons, you would just do 19 minus 16 to get you 3 neutrons. Okay, so this is an isotope. This is an isotope. I could have something that went like 20, 16 oxygen. I could also have something that went 25, 16 oxygen. And all of these will behave the same chemically because they all have the same number of electrons. Like, as you look, there's 16 here, here, and here. There's 16 electrons everywhere. So they will behave the same chemically. The only thing that matters is that they will but they'll be physically different. Because I have 3 neutrons here. I have 4 neutrons there. I have 9 neutrons here. So that's the only thing though, like their mass will be a little bit different. Okay, chemicals, so they behave the same chemically, but just physically they're different. Isotope abundance. So basically nature, nothing exists as just one thing. So like in nature, this is not 100% of oxygens. Like this is not gonna equal 100%. Like this is not just 100% of all oxygens. What it's going to be like is that this thing will exist in nature, but maybe at like 2%. 2% of all oxygens are like this. Like 12% of all oxygens are like this. Okay? I'm just making up numbers here. Like 30% of all oxygens are like this. So like this, it will exist, but in a spread, in like a distribution. Okay? If you were to graph this, you would have like an X and Y axis, and you would have weight, and then you would have their abundances. So everything exists in so you could have some weight be really abundant, and then some might not be as abundant. And something like it's just like a weight. Okay, it will be distributed. It will be distributed. Everything will exist in a spectrum, basically. And to figure out the average mass of something, so figure out like how on the periodic table the average mass of oxygen is 16, what they do is they take the mass of an isotope times its abundance, and they do that for every single isotope they can find. So like you would basically say like this was a real thing, you would do 25 times 2%, then you would do 20 times 12%. Like you would keep doing that, and eventually you would end up at your average mass. They use a microscope, or not a microscope. They use a spectrometer. A mass spectrometer is a tool used to identify isotopes of an element and their relative abundancy. They shoot electrons at the thing, and then like the reason I'm being very vague about this is because I don't know if they're going to ask you this on the AP exam. I need to go and do some research, and if they do, I promise I'll make a more detailed video on this, but I don't think they do. Basically, but they'll hit high energy electrons at stuff, and it'll create positive ions because it's knocking off electrons. When you lose an electron, you have more protons, and all this stuff. Okay, so I'm just going to peruse over this. You can watch this if you're really interested in it, but I think the math is more important. So this neon thing right here, we can figure out the weighted thing of this neon pretty simply. So the neon It says neon 20 is 90% of this world. In our world, it says neon 20 is 90%, 90.48%. And then neon 21 has a 0.27% chance. And I'm just gonna, so neon 21 has a 0.0027, right? Yeah. And then neon 22 had like a 9.25, I believe. Yeah, so basically now what you do is you just type that into your calculator exactly like I wrote it up here. And so you just do 20 times 948 plus 21 times 0.027 plus 22 times 0.0925. And you'll get something that has a weight of 20.18. That's its average weight of a neon. Average weight of a neon. This is what you'll see on the periodic table. When you see a periodic table and it says neon, its weight down here will be 20.18. How did we get that number? They did all this math right here. They figured out all the isotopes and its chances of existing in nature, and they calculated that out. So I don't know what this picture is right here. I don't know, but basically, when you interpret the spectrum, the x-axis will be your mass, the y-axis will be the percentage of the chances of it existing in nature. So like, if I were to graph this thing right here, like literally, I can probably do that really quickly. So you would have like a graph like this. I'll do 20 right here, and I'd create a really tall bar that went all the way up to 90. Then this one right here, 21. I'll say this goes to 2.7%. And then this one right here, I'll do to like right here, 22. This is at 9.25%. This is kind of how it will look. Okay. Of course, they'll say like the element neon, and then you have neon 20, 21, 22, and then they're kind of bars like this, and they'll all be going to different things. Okay. So again, this is the formula. You just take multiply the mass of each isotope by its relative or its fractional abundance. Okay, and that's in decimal. Don't do percentages there. And this in summation. So you keep doing that until you run out of isotopes. We have some questions right here. Boron has 2 isotopes, B10, B11. What is the average atomic mass? Cool. So let's start this on. B10 has a 20% abundance rate. That means B11 has 80%. So 10 times 20 plus 11 times 80. Now we're going to get the average mass. The math is really not hard here. Okay, the math is not hard. The hard part is just knowing what you're doing. So 10.8 is your average boron mass. This one right here, it says an unknown element has 3 peaks. It's 24 or 79. Like, that's a good question. So something of my element has 24 mass. It has a 79% chance of existing. Then it has at 25 has a 10% chance of existing. And so that means at it's like an 11% chance existing at 26. Yeah. So now, what it asks me, what is this element? Okay. The first thing you do right here, they told you everything you need to know. You got to figure out what is the average weight of this thing. So you just do 24 times 0.79 plus 25 times 0.10 plus 26 times 0.11. And this thing has an average mass of 24.32. Now, what is this element? You have to go up to your handy-dandy periodic table and figure out something that has a weight close to this number. Thing that's closest to this number. So 24.32 is our golden number. 24.3-ish. So we're getting bigger. Not there yet. It's magnesium because 24.3. So that's our answer. 24.3 is magnesium. And then the final question they're asking is, when we look at this neon thing, why is the weighted average much closer to 20 than 22? It's a very simple answer. That's because 90% of neon in our entire universe exists at neon 20. Of course, the weighted average will be closer to 20 because that's where most of our data is clustered. I hope that helps. Good luck, guys, and have a nice day. And our answers were right.